Okay, so we will have a look at the code in TensorFlow. First section of code is used to load the data from the CSV files, both clean and the noisy data. Right. The next section of code is used to split the data into 75% test and 25% for training. All right. So, so the next section of code is used to transform the data from 1D to 4D to be used inside the CNN. I've kind of defined some callbacks to keep track of the training times and another function to record the RMSE value. Next section is used to define the neural network. First four lines of code are used to define the convolutional layer, the batch normalization layer, like the ReLU layer, and the polling layer. We've got six of these repeated, and like that's what was required in the paper. So the last layer would be the FCN layer, which job is to give out the ECG signal with all the noise like removed from it. It's like a regression layer, the final layer. Okay, so training starts, training continues. Okay, once the training is done, let's have a plot of the value and trends of the validation RMSE. Okay, it's been plotted. From the plot, you can see that the value has dropped steeply down to a very low value. So that shows that like during training, we were able to train the weights to a good level. All right. Next, let's have a look at the outputs. Okay. So the first plot is showing us like a noisy ECG. We feed this into the CNN for it to denoise. The next plot is showing us the expected output, what we expect to happen if we do denoising properly with our CNN. The third plot, this is the most important one, right? So the third plot is showing us how well our CNN has done in removing the noise from the noisy ECG signal. So I'm like laying the denoise signal on top of the expected output. It looks like they seem to follow each other like really close. And like the final output is the value of the RMC score. It is around 0.1.